Bismillahirrahmanirrahim. Today I'd like to talk about a very important topic, and that is prime factorization of numbers. Let's break down this term itself. The word prime comes from prime factors, or prime numbers. So prime numbers are those numbers that are divisible by 1 and by the number itself. And they're not divisible by any other numbers. For example, 7 is a prime number because you can't divide 7 by anything except for 1 and by itself. On the other hand, 8 is not a prime number because 8 can be divided by 2. So any number is a prime number if it's only divisible by itself and by number 1. So let's give some examples of prime numbers. For example, 3 is a prime number. 5 is a prime number. 7 is a prime number. 9 is a prime number, right? No, 9 is not a prime number because 9 is divisible by 3. So 9 is not a prime number. 10, no, it's not because 10 is divisible by 2 and 5. By far, it's not a prime number. How about 11? 11 is a prime number. So those are prime numbers. So the first thing that we need to appreciate is what is a prime number? Prime numbers are those numbers that are only divisible by themselves and 1. Now, prime factorization means breaking down the number into its component parts until you get to the prime factors of that number. For example, let's take the number 8. Now we know that 8 is not a prime number because 8 can be divided by 2. In fact, when you divide 8 by 2, you get 2 and 4, correct? But then 4 is not a prime number either, so you can divide 4 further and then you get 2 and 2. Now you can't divide this any further. So these are the prime factors of 8. In other words, 8 can be rewritten using its prime factors like this, 2 times 2 times 2. So this process is called prime factorization. It is breaking down the number to its roots. And that's the reason we have this tree over here. So the analogy is quite appropriate actually, because if the tree were 8, the prime factors of 8 would be kind of like the roots over here, like 2 times 2 times 2. So the prime factors of 8, you can think of them as the roots of 8, the numbers that kind of make up 8, okay? So let's do some more example. How about the number 10? How do we break this down? Well, the number 10 is 2 times 5. Well, you can't divide these any further because 2 and 5 are both prime numbers. So the prime factors of 10 are 2 and 5. These are kind of like the roots of the numbers. So let's do another one. How about 32? Well, the prime factors of 32. Now we can divide this as 2 and 16. And that's 4 times 4, right? Well, I can divide 4 into 2, 2 by 2. And this 4 by 2 by 2. So the prime factors of 32 are this. Like this. So those are the prime factors. And you can rewrite 32 as 2. How many 2's do I have? 1, 2, 3. They all happen to be 2's. 2 times 2 times 2 times 2 times 2. So this is prime factorization of 32. Okay? How about 50? How do we do that? Well, 50 is 2 times 25. So 50 is 2 times 25, but then 25 is not a prime number. 25 is divisible by 5, so I can rewrite that as 5 and 5. So the prime factors of 50 are 2, 5, and 5. So 50, another way of writing 50 is 2 times 5 times 5. Now if you multiply 2 by 5, that's 10, and 10 times 5 is 50. So it's just another way of writing the number 50. Let's just do a couple more examples before we finish. How about 20? Well, the prime factorization of 20 would be, okay, well, 2 goes in there 10 times, 2 times 10. But 10 is not prime, so that's 2 times 5, right? So, okay, so that's it. I can't go any further. So these are like the prime factors of 20. So that's 2 times 2 times 5, right? So those are the prime factors of 20. And as a last example, let's do, I don't know, let's do 75, okay? Now, 75 can be rewritten as, well, 2 doesn't go in there, right? Okay, 3 doesn't go in there, does it? Well, maybe it does. How do we know if a number is divisible by 3? One quick way is by adding the digits. So it is 7 plus 5. So one quick way of determining if a number is divisible by 3 is by adding these individual digits. So you add 7 and 5. 7 plus 5, 7, 8, 9, 10, 11, 12, and that's 12. And if this 12 is divisible by 3, then the original number is divisible by 3. So 7 plus 5 is 12, and 12 is divisible by 3, therefore 75 is divisible by 3. Okay, so it is. So then we can rewrite 75 as 3 times 25. Now 25 is not prime. 25 can be further divided into 5 and 5. So that 75 is 3 times 5 times 5. So this is prime factorization. It's a very, very, very important concept. No prime factorization, which is simply breaking down a number into its prime factors. Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.